Hey, let's now see, can we determine how can we identify the right triangle without actually looking at the picture, which means we will just simply utilize the actual formula. Well, to do so, I want to throw a couple of proofs, or should we say Converse and theorem at you. So, saying that, the Pythagorean theorem can be written as an if-then statement with two parts. First part, which is called a theorem, says if a triangle is a right triangle, then a squared plus b squared will equal to c squared. Now, when you reverse the parts of an if-then statement, the new statement is called the converse, okay, of the statement. So the converse says, well, if a triangle is a right triangle, then a squared plus b squared equals c squared. Then the converse says a squared plus b squared equals c squared. If a squared plus b squared equals c squared, then the triangle is a right triangle. So the converse of a true statement may or may not be true. The converse of the Pythagorean theorem is true. And you can use the converse of the Pythagorean theorem to decide whether a triangle is a right triangle. Let's take a look at two or three examples. Okay, first example. We'll call it example A. So we'll say that A is equal to 6. What else we want to use here? Let's say B is equal to 8 and C is equal to 10. So we're given these parts. We want to determine, using these parts, these length of if these actual constitute a right triangle. Well, let's get to work. A squared plus B squared is equal to C squared. A is 6 squared plus B is 8 squared is equal to 10 squared. So I have 36 plus 64 is equal to 100. And then 36 plus 64 is 100, and 100 equals to 100. Yes, indeed, we can conclude that this is a right triangle. Well, let's take a look at another one. Pretty simple. We didn't draw a picture or anything here. So let's call this B. And let's say for B, A is 10. I want to use B is 12. And let's try C is 16. Okay. Will work, I see. Well, let's see. So we'll have A squared plus B squared is equal to C squared. A is 10 squared plus B is I don't want to fool with this multiplication, I can see. But that's alright. We'll go with it. 12 squared is equal to 16 squared. Well, I know 10 times 10 is 100 plus 144, and that must equal to whatever we can look on our chart and see that 16 times 16, our perfect square chart, is equal to 256. Oops. I tell you what, if I'm going to add 4 to 0, I'm not getting No way, Jose. Well, anyway, that was not a right statement. That just didn't work. So 100 plus 144 is 244 is not equal to 256. So we can say it is not a right triangle. I think I want to try one more before I let you go. So let's do so with, change the colors. Let's do so with C. And we have, let's say A is 14, B is 17, and C is 23. And we want to determine if it's a right triangle. So A squared plus B squared is equal to C squared. So we're talking about 14 squared plus 17 squared must equal to 23 squared. Let's go and do some math. 14 squared is going to equal to 196 plus 17 squared is going to equal to 289, and 23 squared is going to equal to 529. OMG. The reason why I'm saying that, I'm looking at adding 9 9 plus 6, and that's going to give me 15. So if I add 196 plus 289, I know we get a number with a 5 on it, and that's true. I'm getting 485. So here I see that 485 does not equal to 529. So the answer is, again, no, it is not. So we can use this without drawing the picture and determine if the left side equals the right side. We do indeed have a Pythagorean theorem. We do have a right triangle, but if not, we do not have a right triangle. So take a real good look at this. I think it's a very useful tool for you when we want to identify whether or not we are actually working with right triangles. Well, we will take a look a little bit deeper off into this in our next segment, as we use our Pythagorean theorem and with different aspects. So here we will look at a lot of ways where we're talking about indirect measurement. We'll look at it finding the perimeter and the area. We'll also take a look at something that's called the Pythagorean triple and how can we identify them. I will see you soon.